Hi everyone, welcome to the virtual JBook. Today we have Tomek from the Wildfly team to talk about what's new in Wildfly 9. So hi Tomek, good to have you.
Thanks. Thanks for inviting me. Hello everyone.
Thank you. Do you want to just start by telling us a bit about yourself?
Okay. I'm Tomasz Adamski. I'm software developer working in Wildfly EAP team. I work mainly on IIoT subsystem, but I've also done some other stuff. I'm working in Red Hat for about a year right now. Before that, I was contributor to Wildfly project, and I'm located in Krakow, Poland.
All right, so thank you. So, so you say you were a contributor before you joined Red Hat. So
Yes.
were you contributing to the Wildfly project? Or?
Yes, mainly to SAR subsystem. I was just learning the internals of the server.
I see. Thank you. Yes, do you want to start your presentation? You got your slides ready?
Yeah, everything's ready. Okay, so I'm going to the presentation now. Okay, can you see it?
Yeah, looks good.
Okay, so I'm starting. So this is a presentation called "What's New in Wildfly 9." So I would like to discuss the new features that are going to be introduced in the newest release of Wildfly that we are just about to release. And to start with, I would like to say a few words about Wildfly itself. So what actually is Wildfly? Well, Wildfly is an application server. It formerly was called JBoss application server, but we have changed the name to Wildfly to distinguish Community Edition from the project, from the JBoss EAP, which is a base of our product. So before the change, we had two projects, JBoss AS and JBoss EAP, and it was a little bit confusing to which project we are referring to. Now we have two projects. They are called Wildfly. This is the Community Edition, and JBoss EAP, which is a base for our product. Those two projects are related as Wildfly is upstream for JBoss EAP, but they serve different purposes. Wildfly goals are introduction of latest innovation with frequent releases. So we are trying to introduce all new trends and all new features that are needed by community at a quick pace. On the other hand, the goal of JBoss EAP project is long-time stability. So we merge the features to JBoss EAP only after we get sufficient feedback from our community. And after that, we are performing additional testing to make sure that the product is ready for long-time stable operation in production. And Wildfly is provided using fast, lightweight, and manageable runtime. So from user point of view, you will be able to notice how fast it works. For example, the server starts in a couple of seconds, even in highest configuration. On my machine, it takes about 2 seconds for a whole server to start. It's very lightweight, so it can be run even on small devices, and it can be managed easily. We provide unified management tools that enable you to manage either one node of the server or whole domain consisting of any number of servers. We are providing full Java AA7 compliant application server and beyond. So we are also adding additional necessary open source APIs that may later become part of the specification. But it is worth noting that because of the extensible nature of Wildfly, you can either trim it down or extend it with easiness to suit your needs. And what's more, it's worth mentioning that although Java EE is the major use case of Wildfly, Wildfly is not tied to it. You can use Wildfly runtime to build different frameworks for different environments and even for other languages than Java. Wildfly is cloud-enabled. It's integrated with our OpenShift platform as service environment. So you can configure it with easiness. With few operations, you are able to run Wildfly in cloud. And finally, Wildfly is an open source project. So you are able to always look at the code and find out directly how it operates. Whenever you are debugging code or just want to know how something works, you can just debug into the code and find out what's happening there. What's more, Wildfly is community-driven project. This means that all discussions are held in public. So if you want to know, in what are the current features that are designed, in what way Wildfly is going, you can get to our mailing list, to our discussion groups, and see what's happening there. What's more, you can become part of Wildfly community if you only like to. We encourage and welcome every contribution, whether it's a small bug report or feature implementation. All contribution is highly welcomed by us. And as I said, we are releasing the new version of Wildfly soon. So this is the topic of my presentation. I would like to discuss and show on examples new features that we are going to introduce in the newest release of Wildfly. So let's start. I would like to start with HTTP2 protocol. We are providing support for HTTP2 protocol in the newest Wildfly. I would like to show you how to enable it in Wildfly with Chrome browser. But before I do it, I would like to say a few words about the protocol itself. What were the goals between the protocol? Well, the protocol is based on SPDY protocol that was initially designed by Google with goal of reduction in page load time. The initial goal was to reduce page time by 50%, so it's very ambitious. And it was meant to be achieved without changes neither to network infrastructure nor to changes in website content. And as a result of that, the protocol addresses the shortcomings in previous version protocol, but it still runs on top of TCP connection, doesn't require web developers to change their websites, and also semantics of the protocol, so that the messages that are exchanged stay the same. The only thing that changes is the way how messages are sent between client and the server. And from the design point of view, HTTP2 is binary protocol with request framing. So it means that each request is encoded in binary format and divided into number of frames. And what's more, frames from different requests can be interleaved in one TCP connection. So as a result, we are obtaining protocol that enable you to concurrently run many requests in one TCP connection. What's more, the requests are prioritized, so the most important requests can get to client first. This directly addresses problems with previous versions protocol when you have to use many connections in order to achieve concurrency. There were some other designs in previous version of protocol, other features introduced that were supposed to address this problem, like pipelining, but it was not widely adopted. So what is currently being done is that browsers are opening many connections to one origin. It has its problems. For example, overhead needed to open many connections. With HTTP2 protocol, this is not necessary, as one connection per origin can be used to multiplex many requests in one connection. And the initial tests are showing that it is actually the case that in previous versions of protocol, it was most of TCP connections were created for one resource. With HTTP2, it switches the most requests. Most TCP connections are used for multiple resources. What's more, in HTTP2, headers are compressed. And this lack of header compression can also be a big issue. Headers are getting bigger and bigger. And because of behavior of TCP connection, when you have to send a large data at the beginning of the connection, it may take a large number of round trips to send the content between client and the server. And in environments when latency is high, this can lead to serious performance penalty. And on the other hand, fixing this, so allowing header compression, can in these environments increase performance very much. What's more, in HTTP2, headers are the headers that are already exchanged are not replied. As protocol, remember what headers will currently exchanged and doesn't resend them in next requests. And finally, HTTP2 has an ability to push data from server to the client. So the client can send a resource to the server can send resource to the client even before it knows that client has asked for it, further reducing the latency. And I would like to show you how to enable the connection, the HTTP2 connection between Wi-Fi and Chrome browser. So we have to do two things to achieve that. First of all, we had to perform standard configuration of encrypted connection. We need encrypted connection because most major browsers, Chrome included, have decided that they will only support HTTP2 protocol with encrypted connections enabled. One of the reasons was that they wanted to push usage of encrypted connections, and change of such big protocol was a good trigger for that. Anyway, Chrome requires us to configure encrypted connection, and we have to do it if we want to use HTTP2, so I will show you how to do it. There's also another issue, as HTTP2 uses TLS extension called ALPN. This stands for application layer protocol negotiation. So it basically establishes application layer protocol during connection establishment. But the problem is that this extension is not present in Java 8. It will be present in Java 9. If we want to use it with Java 8, we have to manually add it to virtual machine that is executing the Wildfly code. Okay, so I will show you how to do this. I have built Wildfly already. I have to modify configuration file. I have to modify Java options. And add to them the command that adds the ALPN jar to the virtual machine. I have downloaded the jar before the presentation. You can get it from Jetty web page. Okay. I will be adding it to bin directory. And we have to specify this directory to the Java options. I'm doing it right now. Okay, I have already done it. Hope that everything will be working fine. Okay. The server has started without any problems. That's a good sign. Okay, so we have done the first thing. We have added ALP and jar to the virtual machine. Now we have to configure encrypted connections. I will use management console to do this. Okay, so what we have to do is we have to add security realm, a new security realm that we will use with HTTP listener. Okay, I have added it. Now we have to configure it. In our security realm, I will configure server identity. I need to specify key store, which contains server private key, which can be used to establish the connection with client. I will establish the connection in which only client identifies itself to the server. Okay, I have done some configuration before the presentation, which is not related to Wi-Fi. That has to be done here. What I have done is I have created a certificate, server certificate, and I have also created a test certification authority, and I have signed this certificate using this authority and added the authority to, Chrome browser as trusted authority. As a result of that, the browser will be able to accept the certificate from the server. And I have I have created the key store that I have prepared here. I will add it to server configuration. Okay. Now we have to address it from management console. I have to specify key store path. This is the name of which I have called it server key store. I have to specify where is it located. It is the option key store relative to, and we are going to use the variable that has this value, just to avoid misspelling a bit. And finally, I have to specify password. I have set a simple password. Okay. We have added security domain. Now, before we reload, I have to configure the add new HTTPS listener. HTTPS listener, I would call it HTTPS. We have to specify following parameters. We have to, of course, enable HTTP2 true. We have to specify security realm, which I called HTTPS. And I also have to specify socket binding, which is HTTPS2, its standard socket binding configuration. Everything seems to work fine. Okay. It seems. Okay, it seems that I have made a mistake when I was configuring the standalone file. Let's look at it once again. No. Java options. That's error here. Now let's restart the server once again. Hopefully now it will be working fine. Okay, there's ALP and jar here. And okay, let's see. Let's see whether it works. Okay, that's a mistake. I have to use HTTPS here. Okay, it works. So I can describe this to you right now. First of all, what I have done also another thing. I have installed the plugin that shows whether okay, the plugin has gone. I don't know why. Let's install it quickly once again. HTTP2 Chrome plugin. I don't know why. It says that it's there, but I can't see it. Let's try it once more time. Okay, it's okay. So I wasn't able to see the blank arrow. Anyway, when you use it on standard interface, you can see an open session. And when we are running it with HTTPS interface, we see that HTTP2 is enabled. So to sum up, during doing this configuration, I was able to configure to use HTTP2 with Chrome. So to recap, we have to add ALP and jar to the virtual machine that is executing Wildfly, and then configure security realm so that the server can authenticate to the client and can start encrypted connection. After we've done it, we are operating on HTTP2 protocol as shown here. Okay. Let's go to another topics. We have introduced server suspend function. What it does, it allows users to move server to suspended state. The server in normal mode processes request normally, and in suspended state, it is not allowed to accept any new request. So it stops processing requests. We had to provide transition between those two states. So after you execute suspend operation, the server goes to suspending phase, and during this phase, it stops accepting new requests, but it allows running requests to finish their work. As a result of that, you can be sure that you are not going to interrupt any running requests. Suspend will allow all running requests to finish, and only after running requests have been finished, it will be moved to suspended state. There is one parameter that can modify this behavior. We have introduced timeout parameter, which enables you to specify maximum time that request has to finish their operation, and after this timeout, server will move to suspended state anyway. So to recap, server will move to suspended state after either all requests have been finished or timeout parameter has been exceeded. The usage example of suspend function may be graceful shutdown. In this case, you can first suspend the server to make sure that all requests are allowed gracefully to finish, and after that, shut down the server. But this is not the only function of suspend state. There may be some configuration changes that you wouldn't like to perform on running server. In such case, you can suspend the server, done your configuration, and resume it. And again, server can be resumed. And it's worth mentioning here that after server is resumed, it starts processing requests immediately, because suspend is designed in such way that no components that make up the server are stopped. The only thing that happens is that components that are responsible for accepting requests are not allowed to do it. And as a result of that, what resume does, it only notifies them that they can resume accepting requests. As a result of that, as I said, no component has to be restarted, no service has to be restarted, and as a result of that, server can resume processing requests immediately after you perform resume operation. So those are management operations connected with suspend function, suspend operation with timeout parameter, resume operation with timeout parameter, and shutdown operation with timeout parameter. Shutdown operation basically first invokes suspend operation and then shuts the server after it's suspended mode. You can also read attribute suspend state from the root of management console to find out in what state server currently is. I will just quickly show the comments. As you see, when server is operating normally, it's in a running state. After we suspend it, it moves to read attribute state, and it shouldn't be accepting. Okay, it shouldn't be accepting requests, and we can resume it. And after resume, it moves to running state, and we can finally shut it down. And as you see, server is shut down after executing this command. So this is server suspend function. Another thing that I would like to talk about is codebase split. We have split the code base so that base architecture of Wildfly, the Wildfly runtime, is versioned separately from the full platform. And the subsystems that can be added on top of Wildfly runtime are located in Wildfly repository, and the core is moved to Wildfly-core. We have provided tooling to facilitate building Wildfly extension and composing them into the server. So there are tools provided that enable you to provide server with only those features from Wildfly that are necessary to you. I will describe those tools and show on an example how to build, how to provision a server. But we'll do it just in a moment. But before that, I would like to say a few words about the distributions that we are providing at default. So first of all, there is core distribution that contains Wildfly runtime, and full distribution that is full application server. But there is also new distribution. It's called Wildfly Web, and it's basically a servlet container. How it is provided. It adds Undertow, which is our high-performance web server, and naming subsystems on top of Wildfly-core. The result is servlet container, but it's worth mentioning that it has all capabilities provided by Wildfly-core. Among these capabilities are management tools and modular class loading. This distribution can be used for applications that prefer to use their own framework inside servlet container. Okay, so those are our default distributions. I would like to say a few words about the tools that you can use to create your own distribution if it's necessary. First of all, we have introduced the concept of feature pack. The feature pack basically is jar describing a server extension. So, in parts of this description are modules, module configuration, subsystem configuration, and content files. Basically, module is our class loading concept, but to understand the concept of feature pack, you can think of module in this context as a group of jars with dependencies on other modules. So we are packing a group of jars in one place, and we are also specifying on what other module given module depends. So for example, we will be seeing JAX-RS module, and JAX-RS module uses JAX-RS subsystem in Wildfly uses REST Easy API. So we are adding subsystem code to module configuration and adding, among others, REST Easy dependency to the module. Subsystem configurations basically, they just specify how different subsystems are configured, and content files are files that are meant to be located directly in server that is going to be provisioned. Example of content files may be a startup script. Feature pack is lightweight, as no jars are included. It contains only the mentioned configurations. So in feature pack, we have only module description. There are no module jars there. Feature pack can depend on other feature packs, and during build, all module dependencies are checked. So for example, if we are let's look at Wildfly Web example that I was talking a moment ago. It depends. It is built using Wildfly-core. It depends on Wildfly-core. So it means that some modules from web feature pack would have dependency on modules from Wildfly-core. During build of feature pack, dependencies, all module dependencies are checked. So feature packs checks whether each module has all its dependencies either in the feature pack itself or in feature pack that it depends on. If all dependencies are there, then the feature pack is created. And it's created using Maven plugin based on configuration file. So we have to configure Maven plugin, add the configurations file, add configuration files, and we will obtain a jar which is lightweight description of part of server functions. And this jar can later be accessed like any Maven, like any jar from Maven repository. When we have feature packs, we can provision server using them. So to do this, we provide a provisioning library. It can be either standalone jar, or it can be embedded in Maven plugin. And its role is to merge all modules, all configuration file and content files from all feature packs into server instance. So basically, we specify the group of feature packs, and provisioning tool gathers all modules, merges all configuration and all content files, and creates server instance. And last thing, module can provision a thick or thin server. It means that created server can either contain all jars from modules, then we're referring to it as thick server, but it can be also thin server. It will be lightweight then, as no jars would be contained inside it, but it would load those jars from your local Maven repository. So those are the possibilities. Now I would like to show it on an example. Let's suppose that you want to create an application that uses REST API, but you don't need any other APIs provided by the server. And what's more, you want lightweight server so that it uses little memory and doesn't use much disk space. For example, you want to deploy it on the cloud and you don't want it to consume many resources. First thing you could do is to just slim down the configuration by removing unnecessary subsystems. This would help with memory usage, but you would still have a lot of jars that are not loaded, but that are contained in the distribution. Using the tools mentioned before, you can create your own server distribution that will contain only those subsystems that you need, and that would be lightweight. And as I said, the example that I would like to present is REST distribution that will enable you to deploy application using REST API. If you want to use default distribution, one of default distributions to do it, you'd have to use Wildfly full, as Wildfly Web does not have JAX-RS subsystem included. But we are going to create feature pack with JAX-RS subsystem and using provisioning tool to create a new server that would be composed from web feature pack and REST feature pack. We have to specify dependency on servlet on the web feature pack, as REST needs servlets to provide a REST API. So we have to add this dependency. Okay, I would like to show you the example right now. We have this is just my basic Maven project. As you see, it contains resources, among which are the mentioned modules, content, and configuration. Let's just quickly look at modules first. We have to gather all modules that are that the JAX-RS subsystem, because basically we have to add JAX-RS subsystem. We have to add all modules that JAX-RS subsystem uses. So we have to gather them. And again, these are only modules configurations. So we are gathering, as you see, it has a few dependencies. We have to gather them into modules directory. Those modules that are not contained in servlet feature pack. So we have to gather them together. We also have to access configuration. This configuration is very simple. We only have to add one subsystem. Of course, the running server would have to use more subsystems, but as I said, provisioning tool will merge them with subsystems from web feature pack. And we don't have to add any content, as all that we need is already in the web feature pack. Okay, so this is the content, the configurations. Let's now look at feature pack configuration. We have to specify, it's also simple. We have to specify dependency on web feature pack. As I said, it's necessary. And also have to refer to show where the configuration is located and what the output file will be. And finally, we have to configure Maven, so that we have to add dependencies to all modules, to all libraries used by the feature pack. So all modules that we gathered should be added to as dependencies to Maven. And then we have to configure a feature pack plugin. So, yeah, we have to add it to the build phase, to the build goal compile phase, and refer created configuration from it. Okay. So let's build it right now. It's built without problems. As you see, it's very lightweight. It only contains about 30 kilobytes. As I said, there are only configurations there, and it can be accessed now from this is description of part of server functions located in your Maven repository. So this is the feature pack. Now we have to use provisioning tool to create a server. So what we have to do, we have to create this. We have to create provisioning configuration. This configuration basically has to list all the feature packs that are going to be merged into the server. So we are referring REST feature pack and web feature pack. Also, we are setting copy module artifacts to true, which means that we are creating thick server as we are including jars in it. So this is a configuration. As you see, it's also quite simple. Now we have to configure Maven. We have to add dependencies to all feature packs, and again, configure provisioning tool the same way that we are doing this with feature pack plugin, and refer to configuration that we have just created. Build it. Hopefully, again, it will work fine too. Okay, we have built it. So now look at the result. We have Wildfly instance here. It's our new REST distribution that added JAX-RS as another subsystem. Let's look at it. It contains 40 megabytes, so it's only slightly bigger than. Let's go to Wildfly. Let's go to Wildfly project to look at web distribution. As you see, it's only a few megabytes bigger than the web distribution, but much smaller than the full distribution. Let's just look. Okay, the full distribution is much larger. But the last thing that we have to check is whether it's working. Hopefully it will be. It started. Okay, now let's deploy an application to it. This is application based on one of our quick starts. It's a very simple application. It basically allows you to click a link, which moves you to a REST resource. But as you see, it definitely uses a REST API. and we are going to deploy it to the server. So it would be home, examples, mode cluster, oh, sorry, provisioning, rest dist, target, rest, standalone deployments. Okay, it seems that it is deployed, but let's confirm it. Okay, as you see, we have our simple application, which allows you to access REST resource. So to recap, using feature pack and server provisioning tools, we are able to create new distribution that contains only subsystems necessary for our use case and produces lightweight server distribution that handles this goal. We are also providing another project that is currently being developed that allows you to achieve the very similar goal, so that you would able to create. Okay, this project is called Wildfly Swarm, and you can use it to create fat jars with embedded Wildfly. So what it means is that it enables you to create running jars with embedded Wildfly, but with only those parts of Wildfly that are necessary. It's built using Maven plugin. So how it works? You have your standard project, which, for example, contains some servlet. Then you just have to change your Maven configuration. And from this configuration, you are adding another plugin, Wildfly Swarm plugin, and you are specifying as dependencies what subsystems are you going to use in your application. What Wildfly Swarm does, it is embeds your application into Wildfly, but using only those subsystems that you have specified. And as a result, it produces runnable jar. And use case of Wildfly Swarm may be microservices, and as you may want to use it to create your own microservice, again, with only those parts of server that you need for your use case. Okay, another feature that we are going to introduce in Wildfly 9 is enabling the ability of using Wildfly as load balancer. This Wildfly can be used as mode cluster-based load balancer. So to put it in context, I would like to say a few words about mode cluster. Mode cluster is HTTPD-based load balancer. So till now, if you wanted to create Wildfly domain consisting of load balancer and backend servers, you had to configure Apache server as a frontend. Mode cluster has, comparing to simpler load balancers, a few advanced capabilities. Among them are dynamic configuration of HTTPD workers. What it means is that you can configure it in a way that hosts in domain are discovered automatically. You don't have to do it, as you can also create standard list of servers, but it is possible to configure in that way that mode cluster will use multicast advertising to advertise itself to the nodes, and the nodes will use its management protocol to register in it. So you can configure your domain in the way that all nodes will be added and removed automatically when they start without additional configuration. What's more, Mode Cluster enables server-side load balance factor calculation. What it means is that servers can, using management channel, send their business data to the load balancer. Those business data, the metrics are configurable, but it means that server can decide to which backend server sends the request based on the data that it obtained from the servers. And finally, fine-grained web app lifecycle control. It means that servers have protocol messages that can inform the load balancer that they go down. So we are avoiding situation when server goes down and load balancer has to learn it itself, or even worse, it sends request and this request can be processed. We are providing Mode Cluster is providing functions that messages that enable the balancer to notify that the server is going down. So those are the advantages, the capabilities of Mode Cluster itself. But from now on, from the 9th edition of Wildfly, you can use Wildfly as Mode Cluster-based load balancer, and it would have additional advantages compared to normal Mode Cluster usage. And those advantages, among others, are, first of all, one tool can be used to manage front and backend servers. As I said at the beginning of the presentation, we are providing management tools that enable domain management. It means that you can create different server groups. You can manage many servers on many hosts using one tool from one place. As a result of that, you can now create Wildfly as load balancer as one part of the domain, and other nodes that would be backend nodes using the same tool. As a result of that, you will be able to manage and start whole domain from one tool, and there will be no need to start HTTPD server. Start and configure it. And another advantage of using Wildfly as load balancer is that it can be used. That the performance can be improved because of undertow itself, and because of the possibility of using more efficient protocols such as HTTP2 between load balancer and backend servers. Okay, so this is the ability to use Wildfly as load balancer. Another thing that I would like to talk about is offline command line interface support. We provide ability to embed a Wildfly process inside the command line interface process. What it means that now, if you want to perform configuration but don't want to start the server, you can do it. You can do it. Yeah. So I'm going to show this on example. I'm going to show this on an example. Okay, we have. Let's start the server. Something's wrong here. Let's skill to make sure. Probably I haven't stopped the the REST distribution. Okay. Okay. Sorry, I made a mistake. We are not starting the server, just start CLI interface. We are embedded. We are going to embed the server. As you can see, we can now perform some configuration changes. Let's look at for example, okay. Yeah, let's change some property in a JBoss subsystem. For example, log system exceptions. You see it here. It's set to true. As you see, we have the ability to change the configuration. We can just make sure that the server is indeed not working. Okay, it is not working. Now let's go to okay, I don't know why there is no system. So let's change so attribute in another one, right attribute. Let's choose some our sub-deployments isolated, for example. Okay. We have some problems here. Anyway, you are able to see that although we are not running the server, we have ability to change the name. For example, let's change the name attribute. It's just okay. We have see that it is changed, and server is not running. And finally, we have performed switch to OpenJDK ORB in newest release of Wildfly. OpenJDK ORB is downstream project of OpenJDK. It means that it is maintained as part of OpenJDK, so we are expecting better stability here. And what's more, Java reference implementations ORB, Glassfish ORBs, is based on OpenJDK 2. So we are expecting that better interoperability with the reference implementations and other implementations that commonly use JVM ORB 2. Okay, so that's all for me. I would like to show the references. Those are at the top of the page. You can see the Wildfly.org page with all news about Wildfly, the GitHub location of Wildfly, and Twitter. I have also included the location of JBoss EAP product and Quickstar's location. Okay, so that's all from me.
Thank you, Tomek. That was great. Thanks a lot. We've got some questions from IRC. So the first question is regarding the suspend feature.
Okay.
So we would like to know. Let me find the question. Okay, so are transaction rollbacks forced after the timeout? So I think what they would like to know is how in-flight transactions are handled when the application server suspends. And I think in particular what happens if a transaction times out whilst the application server is suspended.
I believe it's a complex topic, and it depends on configuration of different transaction. And to be honest, I would like to I would need to check it to provide the answer that I'm 100% correct. Nevertheless, I believe that it would also depend on the timeout that is configured for the transaction itself. So I believe that if timeout is longer than the timeout declared for the suspend timeout is shorter that the timeout for the transaction, that would behave the same way as stopping the server without the suspend feature, without waiting. But as I said, I would need to check this to provide answer.
Okay, so I think what you're saying is that when the application server is resumed, any transactions that have timed out in the meantime will be rolled back.
Probably yes. We'll have to check it.
I think that makes sense. I think I'm not quite sure what other options you would have, I suppose. Yeah, it seems sensible. But okay, if you don't know offhand, then that's fine. But that seems like a sensible approach. The next question we had was, can you use remoting and Hornet queue of a mod cluster?
I'm sorry?
Can you use remoting and Hornet queue over mod cluster?
I'm not aware of such possibility.
Okay.
So it can be only used to create cluster based on HTTP protocol. If you want to, with JBoss remoting, we are providing our own clustering included in JBoss client. So mod cluster can only be used as HTTP load balancer.
Okay, good answer. Thank you. And maybe apologies if you've already said this, but when is Wildfly 9 going to be released? Have you got an expected date?
Okay. You got me now because I don't know the exact date. We have the candidate release to right now, so it's going to be released within the next weeks, within a few weeks.
Okay, great. Okay, so yes, we got a follow-up from the mod cluster question, but I'm not quite sure I'm following it. So the same remoting would be the EJB communication.
I'm sorry. Is it, if you?
Okay.
What I mean is that we are providing cluster functionality in AJB client with remoting. So you can configure clustering too with AJB using remoting protocol, but not with mod cluster. Mod cluster is meant to be used with HTTPD protocol.
Okay, I think yeah, he's got the answer. The problem is that the video lags by about a minute, which makes it difficult to ask questions. Because the IRC is obviously, the lag is negligible, but the video lag is a minute. So as I'm talking now, the people who are watching won't see it for another minute. Makes sense. I think, but anyway, I think you got the answer he needed, so that's fine. One of the questions I wanted to ask you was, are there any, so I think you've started working on Wildfly 10 now, is that right?
Yes.
Yeah, is there any kind of common themes of features that we can expect in Wildfly 10?
I can just give you an overview of those features. Just give me a second.
Yeah, I'm just kind of curious at a high level what type of things we can look forward to.
Okay, so what we are going to introduce in Wildfly 10 is a new version of core. We also are moving from HornetQ to ActiveMQ Artemis library. We are going to implement JMS graceful shutdown. So because graceful shutdown can be implemented differently in different subsystems. So the implementation for JMS will be added in Wildfly 10. And we are also going to add singleton HA deployments, improve user interface for large domain, and we are going to add hierarchical profiles. That's the list that I have of the new features that are going to be added.
Okay, cheers, thanks. So I think maybe it might be worth expanding on what you were saying about moving away from HornetQ. So my understanding is that the HornetQ and the ActiveMQ have merged the code bases, or is that right?
To be honest, I don't know many details about messaging subsystem, so I can't give you a full answer here.
Okay, so the question, we've just had a question now that's saying, will Wildfly integrate ActiveMQ instead of HornetQ?
Again, I wouldn't like to answer the questions for JMS subsystem, as I'm not expert here.
Okay, no problem. Okay. Okay, I'll just see if there's any more questions. So I'm just going to wait a short while to see if I have any more questions. But yeah, okay. So someone in the chat room saying that from what I know, Project Artemis, if that's how you pronounce it, is an integration of HornetQ bits into ActiveMQ, which will become ActiveMQ 6. But that's roughly kind of what my understanding was. So the HornetQ team work a couple of desks away from me, so I hear what's going on a bit, but unfortunately I don't know the details exactly. Okay. Okay, so I don't think we've got any more questions. So thanks a lot, Tomek, for a good talk.
Thank you very much.
Good luck for your talk at DevOps.
Thank you.
Thank you. Speak to you later. Bye, everyone. Thanks for watching.
Thank you, everyone, for listening.
Thanks, Tomek. Bye, everyone.
Bye.